Next we'll discuss about simple axle and wheel. So you can see the diagram. This is the wheel, this capital A, this is the wheel, and this is the axle. Both are mounted into the same shaft, and usually the shaft is mounted with the help of bearing to reduce the vibration and frictional resistance. In this diagram you can see a string is attached at this wheel A. A string is wound around the axle B. Here you can see the string is wound around the axle B, which is used to lift the load W, and in the wheel the string is attached in the opposite direction to the string attached in the wheel, so in the axle. So here you can see at this end we try to put some effort, we try to apply some effort. So if we'll try to apply some effort at this end, this will rotate. So this will rotate in this direction, but here the string is attached in this end, so both are mounted into the same shaft. So if this will rotate, this will also rotate. If this will rotate one revolution, this will also rotate one revolution, but the strings are attached in the opposite sense. So if I'll pull in this side, it will move like this, and it will move in the opposite direction, the string. So it will try to raise the load like this, but I will apply the effort in this direction downward, but the load will lift upward, you can see. So suppose this wheel has diameter capital D and the axle diameter is small d. Suppose the load to be lifted is W and the effort applied to lift the same load is P. So what will be the velocity ratio? Velocity ratio is distance moved by the effort divided by distance moved by the load. So for one revolution of shaft, this will also rotate one revolution, this will also rotate one revolution, both are mounted in the same shaft. So what in one revolution, what distance it will cover? So its diameter is d, one circumference, one revolution means it will cover one circumference. What is the circumference of a circle? That is pi d. Similarly, it will also move one revolution. So for one revolution, it will also move pi. Its diameter is small d, so it will move like this. So what will be the velocity ratio? Distance moved by the effort, this is this side, divided by distance moved by the load, that means capital D by small d. So what is mechanical advantage? It is W by P. And what is efficiency? Mechanical advantage by velocity ratio. Here we will solve two questions on simple axle and wheel chapter topic. So here it is mentioned that a simple wheel and axle of diameter D, diameter is 300 mm and 30 mm. That is, wheel diameter is 300 mm and axle diameter is 30 mm respectively. What is the efficiency of the machine if it can lift a load of W equal to 900 Newton by an effort of 100 Newton? So we have to find out the efficiency value. So efficiency is mechanical advantage by velocity ratio. What is mechanical advantage? Load to be lifted by effort applied, that is 900 by 100 equal to 9 Newton. Sorry, there is a constant value, no unit, same unit got cancelled, so 9. So what is velocity ratio? Velocity ratio is distance moved by the effort divided by distance moved by the load. So we apply effort in the wheel side and the load is lifted in the axle side. So suppose the wheel diameter is capital D equal to 300 mm and the axle diameter small d equal to 30 mm. We know that both are mounted in the same shaft, so for one revolution of wheel, the axle will also rotate one revolution. So what is the circumference? For one revolution it will cover one circumference. So what is the circumference for a circle? That is pi d. So the effort will move pi capital D and the load will lifted by distance pi small d. So this is the velocity ratio, capital D by small d, pi got cancelled. So 300 divided by 30, so 10. So velocity ratio is 10. So efficiency is mechanical advantage by velocity ratio, that is 9 by 10, that is 0.9 equal to 90%. So in this case the efficiency of this machine is 90%. So another question we'll solve. A drum weighing 60 Newton holding 240 Newton of water to be raised by the wheel by means of a wheel and axle. The axle is 100 mm diameter and wheel is 500 mm diameter. If the force of 120 Newton, that means effort, is to be applied to the wheel, find the mechanical advantage, velocity ratio and efficiency of the machine. So mechanical advantage is, what is mechanical advantage? Mechanical advantage is effort to be applied by load to be lifted. Mechanical advantage is load to be lifted by effort to be applied, so W by P. So what is the value of W? So here it is mentioned that a drum of 60 Newton holding in 240 Newton of water. So here 60 Newton and holding 240 Newton of water. So total weight to be lifted is, it will lift the drum plus the water. So total weight is 240 plus 60. 300 Newton weight. So here the effort is given as effort force 120 Newton applied. So what will be the mechanical advantage? 300 by 120. What will be the velocity ratio? Velocity ratio is pi capital D by pi small d. I have already described you how this formula comes. So what is the value of capital D is 500, small d is 100. So it is 5. Velocity ratio is 5. What is the value of efficiency? Mechanical advantage divided by velocity ratio. That implies 300 divided by 120 divided by 5. So 300 divided by 120 into 5. So 5, 6, 30, 60, 62 half. That is 50%. So in this case the efficiency of this machine is 50%. So these are the simple problems in the topic of simple axle and wheel. So I think now you can solve this type of problem if it comes in the exam.